Good day, everyone. We are presenting our research entitled An Experimental Assessment of Basalt Aggregate Utilization in Class A Concrete Mixes. This study evaluates the feasibility of using basalt aggregate as a replacement for conventional coarse aggregates in concrete. Basalt aggregate was used in this study as an alternative coarse aggregate material. Basalt is a dense, volcanic, igneous rock known for its durability and strength. The basalt aggregates used were obtained from a local source and prepared with sizes ranging from 10 to 20 millimeters. To maintain consistent moisture content before mixing, the basalt aggregates were oven-dried at 200 degrees Celsius for 30 minutes and allowed to cool overnight. The materials used in this experiment include ordinary Portland cement, fine aggregate or sand, conventional coarse aggregate or gravel, basalt aggregate, and potable water. The equipment used includes weighing scales, mixing tools, slump cone apparatus, tamping rods, steel molds, and PVC cylindrical molds with dimensions of 4 inches by 8 inches. The first batch prepared was the control mix containing 0% basalt replacement. The concrete mixture followed the Class A 1:2:4 mix ratio of cement, sand, and coarse aggregate. The dry materials were first mixed thoroughly before water was gradually added until a uniform mixture was achieved. The second batch consisted of 50% basalt aggregate and 50% conventional gravel as coarse aggregate replacement. The same mixing procedure and water-cement ratio were maintained to ensure consistency among all concrete mixtures. The third batch utilized 100% basalt aggregate as a complete replacement for conventional gravel. All mixtures were manually mixed until a homogeneous concrete consistency was achieved. A slump cone test was conducted to determine the workability of each concrete mixture. The concrete was placed inside the slump cone in layers and compacted using tamping rods. After lifting the cone vertically, the slump of the concrete was observed and measured. Before casting, the inner surfaces of the cylindrical molds were greased to prevent concrete adhesion. The concrete mixtures were poured into the molds in 3 layers, and each layer was compacted using 25 tamping strokes. The top surface was then leveled to produce a smooth finish. After 24 hours, the concrete specimens were carefully removed from the molds through the demolding process. The cylindrical specimens were prepared for water curing. The concrete specimens were submerged in a curing tank filled with water. The curing periods were conducted for 7 days, 21 days, and 28 days prior to compressive strength testing. Thank you for listening.